Okay, boys and girls, ladies and gentlemen, and people, this is scenario 1 that we talked about in class with the go-car. To remind you of what happened, we had the go-car sitting at rest on the track. I obviously have the drawing here. Hopefully you can see that. This should look the same as what I had on the board. And, oh boy, let's see my laser pointer. So we have a motion map here indicating that it is at rest, that there is no acceleration, 0. And then we drew a force diagram that shows that we have balanced forces. We have the gravity force acting down, we have the force of the track acting up on the car, and those two forces are equal amounts, opposite direction, and we called those balanced forces. Oh, I didn't write that yet. Let's see, balanced forces. There you go, balanced forces. That was scenario 1, which we already did together in class. Now, let's take a look at scenario 2 and see what that should look like. So for scenario 2, we had the go-car that was traveling with a constant velocity across the track. Constant velocity. So what does the motion map look like for a constant velocity? Now remember, you were supposed to have done this in class, or I should say for class today. So the motion map for the go-car should look like this. If you haven't done it, then pause the dang video and do it quickly, and then see if you did this correctly. Now, I don't know where the object was when it started. I'm just going to say it started at the 0 position because I can. Because it says constant velocity, I now know that the arrows should be all about the same length, and they should be going all to the right. Why? Because that's the direction it's traveling. My A then in this motion map should be what? I can't hear you. Correct, 0. The A should be 0 because we don't have acceleration since it is traveling with a constant velocity. Back to the force diagram. I drew them both back in here on the second diagram because I believe we still have the force of gravity acting on the car. We also still have the track acting on the car. The question becomes, do we have anything else? Are there any other forces acting on the car in this scenario? So, take a look here. Is there anything else in our picture that would show that there's something touching the car? Because that would be a contact force. Is there anything besides the track that's acting on the car? The answer to that question would be no. And some of you are going to say, yeah, but you pushed it. Your hand pushed it over there on the side, behind the chair. Okay, yes, my hand pushed it behind the chair. I mean, it was behind the chair and my hand pushed it. That's not what's happening right here. Was my hand pushing it as it went across the track with a constant velocity? The answer to that question is no. My hand was no longer pushing it. Therefore, we can't put a force of hand on car over here because my hand wasn't pushing it in this scenario. Not while it was traveling with a constant velocity across the table. Now, some other folks try to put things like this in there. I hope I can draw this in there and then not make it, or make it not stay. We'll see. Some people put things over here and say force of motion on car. Let me ask you, is that, oh, I hope I can erase this. I really hope I can erase this. Force of motion on car. Is motion an agent? For instance, what's the agent of the gravity force on the car? That's the earth. The earth is the agent. That's the one that's acting on the car. What's the agent of the force of track on car? It's the track. What's the agent of force of motion on car? There isn't one. Motion is not a thing. It's not an actual object that can push on something else. Therefore, it is not an agent of force. Some other people have put things like inertia or momentum words in there. Those are also not objects that can push or pull on other objects. So you cannot list those as agents of a force. The reason we use agent-object naming is to keep you from just making things up and making up forces that don't actually exist, to make yourself feel better, but because since it's moving to the right, you think there has to be a force to the right, and there just isn't a force to the right. Oh my gosh, look at this. I can undo. I'm undoing right now as we speak. So there is no force of motion or force of momentum or force of inertia or force of whatever other name you'd like to bring up. The only two things that are acting on the car at that moment are the earth, because of the gravity force that it's acting, and the track, because it's pushing up on the car. Everybody got that? Fantastic. So what kind of forces do we have here? We have balanced, oh boy, balanced forces once again. Moving on. Next. So now, scenario 3. That's where the force probe came in. So there was a force probe here that was acting on the car, pushing the car, and making it speed up. So what does the motion map look like for that kind of motion? I hope that you've done this. If not, pause the video and do it. So the motion map should be arrows that start small because it wasn't moving very fast at the start. In fact, it started from rest, and it got faster and faster and faster, meaning the arrows get longer and longer and longer. That means the A is what? I hope you're thinking correctly, that it's in the same direction that it's moving. Yes, then you'd be correct. For the force diagram, I included the force of gravity on car and the force of track on car because those have been there the whole time, and they've been equal amounts in opposite direction the whole time. Do we have anything else acting on the car? What is that? We have, yes, the force probe. So we have the force probe acting on the car. What direction? Like that. How long should you make the arrow? I don't care. But that's the force of the probe on go car. There you go. Is there anything else acting in this scenario? It doesn't look like it. When I look at the picture, I don't see anything. Oh my gosh, what's that? I don't see anything else that's acting in there besides the track and the probe and, of course, the gravity force, which we can't get away from. Now, the next question is, are these balanced or unbalanced forces? Well, this iPad's killing me right now. The gravity force and the force of the track are balanced, but is there anything over here to balance out the force of the probe? No. Therefore, we would call these forces unbalanced forces. Now the next question is, what direction are the forces unbalanced? So which way are they unbalanced? If you were thinking to the right, then you are correct. It's to the right. Moving on. Scenario 4. So, scenario 4 here, we have the go car with the force probe acting again, but now the force probe's on the other side of the car, and it's acting in the other direction, and it's actually slowing down the car. So how do you show the motion map where the car is slowing down? Let's see here. There's the zero position. There's the positive direction. And that means the arrow is going to be starting what? Long and getting shorter as time goes on, and eventually probably stopping. That means our A has to be what direction? What's that? I couldn't hear you. Left. Sure. Opposite direction as the motion. Remember, when it's slowing down, the A has to be in the opposite direction of the motion. Now, I again have the force of gravity on the car and the force of the track on the car in the diagram because those have been there the whole time. What else do we have acting on the car? What's that again? The what? Yes, the force probe is acting on the car. In what direction? Well, to the left this time. And again, we'll name it force. Oh, crap. Oh, no. Oh, there we go. I saved it. Force of probe on go car. Notice I've been abbreviating things a little more instead of writing all the words out. Hopefully that won't mess you up. So force probe on go car. Man, my writing is horrible on this thing. Now, that force is to the left. Is there anything out here to the right that's happening to the car to make that balanced? No. Therefore, the forces in this case would be what? Unbalanced. Oh boy, this is getting worse. Unbalanced forces. In what direction are the forces unbalanced? Was that? What'd you say? Yes, the left. So the forces are unbalanced to the left. Hopefully that's making sense to you. We have unbalanced forces. Now, what if we had a tiny little force like this to the right? Are the forces still going to be unbalanced? Again, this is hypothetical. What if? Are the forces still going to be unbalanced? Yes. And why? Because this one here is bigger than this one here. Therefore, that's still unbalanced to the left. Just because there's 4 forces, so it doesn't take an even number to make balanced and an odd number to make unbalanced. It has to do with how big are the forces that are acting and in what direction are they acting. Now I hope I can undo the writing. No, I can't. Oh my gosh. Seriously? That means can I erase it? Oh my gosh, can I erase it? It won't let me erase it. Oh my gosh, this is stupid. This thing is just killing me right here. I can't even erase it. I can't erase it. All right, here's what I'm going to do. Here's what I'm going to do. That's not there. That right there, that's not there. Don't put that in there. All right, here we go. We have to come up with, oh boy. So we have to come up with the big ideas. Big ideas. So, oh my gosh, this is terrible. The writing is just awful. So, hopefully you're noticing some things in your diagrams, okay? Hopefully you're noticing some things. Here's what you should be noticing. When you have balanced forces, when the forces are balanced, what's happening in our motion maps? What are you noticing in our motion maps when the forces are balanced? Hopefully you're noticing there's no, oh my gosh, oh, what is happening right now? There's no change in motion. And what do I mean by a change in motion? There's no acceleration. Are you looking back at those? Hopefully you're looking back at your scenarios and seeing that there's no acceleration when we have balanced forces. No change in motion, no acceleration. Then what are our options? What could the object be doing? Well, the object could be at rest, or doing what? Or motion with, oh my gosh, constant velocity. Those are our 2 options. If you have, that's an O, oh my gosh. Those are our 2 options if we have balanced forces. That's what we're seeing in those diagrams. Now, what if we have unbalanced forces? Unbalanced forces. What do you see in the motion maps of the scenarios where we have unbalanced forces? I hope you're seeing that we do have, yes, there is a change in motion. And what do I mean by change in motion? I mean acceleration. Do you see that both of the scenarios numbers 3 and 4, so this is scenarios 1 and 2, this is scenarios 3 and 4. Yes, we have a change in motion. There is acceleration when the forces are unbalanced. What's more is this. Look at your motion maps. You may have to pause the video. Look at the motion maps and tell me what's happening with the acceleration as compared to the unbalanced force. Look at the imbalance and look at the acceleration. What are you noticing? Did you pause the video and check? Pause the video and check. Look at your diagrams. What are you noticing? I hope you're noticing this. They're in the same direction. Unbalanced force. Oh boy. Unbalanced force. And, oh my gosh, and acceleration. This is the worst writing I've ever seen. That's a C right there. Can I even erase that? I don't even know. Oh my gosh, it did. Did it erase this time? Why does it not always work? I don't know. Probably because it's an iPad. Unbalanced force and acceleration are always in same direction. There we go. The unbalanced force and the acceleration are always in the same direction. There we go. Oh, how neat is that? That's pretty neat. So, I hope that the big ideas are making sense. You're going to need to use the big ideas to work on and to interpret all of the scenarios that we will be looking at and will use this entire unit. Okay? So, these are the kinds of things you need to commit to memory. Hopefully you can do that, and hopefully you'll make sense of the assignment that you're going to get. All right, I think that's about it. See you later.